Everyone, welcome to SDN Beat again. In this video, we'll be discussing network virtualization and network functions virtualization. So let's get started. As you can see, I have gathered some pictures which I will use to explain network virtualization concept. And let's first remind ourselves why we need virtualization in general. Why would we need to virtualize networks to begin with, right? As you remember, we are virtualizing servers to use hardware resources more efficiently. So in server virtualization, if we have one physical appliance, one physical server, we could allocate certain amount of CPU, memory, and storage resources to one virtual machine. And we could have multiple virtual machines on top of same physical server. In that way, by using the hardware resources more efficiently, we are getting more and more different, we're creating more and more different virtual machines which serve completely different purposes, which have completely different applications installed on them. And that allows us to use server capabilities and physical resources more efficiently, and that gives us more flexibility. In networking, however, things are a little bit different. So as you can see in the first picture, we already indicated that virtualization of the hardware per VM tenant, replication of hardware constructs as virtual hardware. Basically, a lot of virtual machines using hardware resources such as CPU, RAM, and storage. But in network virtualization, there is no virtualization of hardware. We are not using CPU storage or RAM resources of router, switch, firewall, whatever. We do not touch hardware resources of network devices. Instead, we are virtualizing the network infrastructure itself. So the network. So we have physical topology, and based on this physical topology, on top of that, we're creating an overlay network. So our physical topology consisting of nodes is our physical underlay infrastructure. And on top of that, we can create a lot of virtual topologies by allocating virtual nodes in a certain way. And then we can isolate these newly created virtual networks from each other and manage them one by one, which gives us security by isolation and also flexibility and ease of administration. So basically, we are not virtualizing hardware of network devices, but instead we are virtualizing the underlying physical network infrastructure. And the newly virtualized network is called an overlay network in network virtualization terminology. And in the second picture, you can see we have a different concept, NFV, which stands for Network Functions Virtualization. So what is the difference? Network virtualization can be used it's a more general concept. For example, let's say we have a virtual machine. We just deploy the virtual machine using VMware, right? And now we can create a virtual network interface in that machine, and then we assign one of our physical network interface cards to that newly created virtual interface. So this is one of the examples of virtual networks, like network virtualization. But virtualizing functions of network is completely different concept, right? So as you can see in the second picture, we have the hardware resources, the compute, memory, network, and then we have a virtualization layer. On top of that, we have virtual compute, memory, and network, and this is our NFV infrastructure. And then we have virtualized network functions. So the idea of VNFs is basically that you have certain service, right? You have a certain service on your device. Whether it's router or switch, whatever, it's firewall. Let's say it's a firewall. We have a physical firewall, and that firewall protects your internal network from external threats. And now you have an order, like as a business need, you have to install a second firewall on different branch or on different campus network. Let's imagine. So traditionally, as a network engineer, what we were doing is we were trying to obtain a new physical appliance, purchase that appliance, we have to pay for that, and after purchase we have to wait until it is delivered to us, and after it is delivered we have to install it physically somewhere in the office or in data center, in server room, whatever, and then you have to configure it exactly as your first firewall, and maybe even with differences because it might be from a different vendor, right? It might have a different syntax, it might have a different, terminology and stuff like that, basically. So to alleviate this issue, we are going to use network virtualization of functions, right? So functions, we're taking this, let's say, firewall capability from the first firewall. We are virtualizing it, meaning that we're creating another virtual machine or another virtual appliance, and we're replicating exactly the same function of firewall and inserting this function, this virtual function, to the virtual appliance. What it exactly gives us, how it benefits us, what is the point of doing that, you might ask. And I have collected the benefits right here, why this method makes more sense. So basically, first, let's start by scalability. Virtual network functions can be easily scaled up or down to meet changing network demands without the need to purchase and deploy new hardware. Basically, by using VNFs, you don't have to purchase or deploy new hardware. You can basically extract this function from the device, replicate it, not necessarily extract everything, but just replicate the same functionality and install or deploy it in somewhere else. So it's very flexible in terms of roaming. You can just take it from somewhere, this piece of software, and then deploy it somewhere else in your network using basic, let's say, x86 servers or any other appliance, whatever. Number two is flexibility. Virtual network functions can be easily moved or replicated across different physical locations or even cloud environments, depending on the needs of the network. So not only you can move these VNFs to a different machine, to a different virtual appliance in your infrastructure, you can also move it directly into the cloud. So if you are using some public cloud service, you can easily replicate this function and use it, deploy it on the cloud, and you don't have to obtain any other hardware. So it's very flexible. Cost savings. By virtualizing network functions, the company can reduce the cost of deploying and managing physical network appliances, as well as reduce the cost of hardware maintenance and upgrades. Because you are not purchasing a completely new hardware device, you will spend less money. You will basically save a lot of money, and on top of that, you don't have this administration burden. So you don't have to install it, deploy it, upgrade its software. So all of these overhead tasks are basically going away. And the last benefit is agility. These VNFs, the company can quickly and easily deploy new network services or make changes to existing ones without the need for extensive hardware deployments. It's so flexible that you can, after replicating the network function itself, you can modify it exactly as you want, and you can deploy it wherever you want. And it's very agile, it's very flexible, and it's very secure. And it's secure because network virtualization allows you to segment your logical networking topology into different segments of logical network groups, which are isolated from each other, it kind of works like VLANs. But the problem with VLANs is that VLANs are primarily a layer 2 concept, so you cannot span the same concept and use it somewhere else in your network, like if it's up from layer 3 level on OSI model. And also VLANs are limited by physical infrastructure itself. So if you have a switch with certain amount of ports, you can have that much, let's say, broadcast domains, and that's pretty much it, right? If you segregate them efficiently. But network virtualization allows you to take entire infrastructure, doesn't matter if it's layer 2, 3, whatever, and you can virtualize this physical infrastructure and create a different overlay network. And in this overlay network, which uses protocols like VXLAN, Lisp, and so forth and so on, you can create virtual network groupings and manage them one by one separately. It will be easier from administration perspective to manage and operate your network. From security standpoint, again, because those virtual groupings are isolated from each other, you can easily assign certain groups to certain departments, let's say, or certain, tenants or stuff like that. And basically you are using your physical infrastructure more efficient because there could be a lot of overutilized links, a lot of underutilized links, and a lot of devices that do not provide much of a benefit. You can use them more efficiently, and that basically gives you the agility and flexibility to increase the speed of operations you have as a network engineer to complete your tasks better and with much more quality. And the last portion I would like to mention in this topic is what role does SDN plays in all of this? Basically, we need SDN controllers to manage these virtualized networks, right? So let's say you already collected, grouped, and virtualized all of your networks on the overlay, and now you have to find a way to actually administer those networks, to actually manage them, modify them based on business needs or whatever. And to do all of this orchestration and management, you need SDN controllers. So SDN works alongside with network functions virtualization concept together and allows you to utilize, and orchestrate your physical network infrastructure much more efficiently and effectively. That's pretty much it. Thank you for watching. If you have questions, don't hesitate to comment below. I would love to answer to your questions. And thanks for watching. Make sure to subscribe. You can follow us on Instagram as it is indicated on the screen. And thanks again for watching.